All right, hello out there in remote land. Today we're going to chat about physical weathering, right? We talked about rocks and minerals. With minerals, we talked about their hardnesses. Um, with different type of rocks, we realized that sedimentary rocks are more soft rocks, they call them, whereas the metamorphics and the igneous tend to be a bit tougher, a bit harder rock. And all this plays a role in how different materials are weathered. Of course, when you weather rocks down, you break it into those particles, right? Remember, you have your boulders, cobbles, pebbles, sand, silt, clay. And this, of course, weathering and erosion is all about the breaking down of sediments and the transporting, and it's kind of the next step in a logical cycle there. Okay? So, two beautiful pictures on the bottom, right? Mother Nature certainly is absolutely gorgeous, but also destructive in a sense, right? Tree roots can easily crack rock as they grow and expand. Running water is very abrasive. It'll literally cut through rock like a knife, right? The Grand Canyon was carved out by water. That was all solid rock. So anyway, very exciting unit. And we're going to start out with the physical part of it, right? Physical weathering. All right. Describe why the Sphinx in Egypt appears the way it does. So take a minute, think it over. Obviously, it didn't always look this weathered, right? It was more pristine. Like think Mount Rushmore, right? Those faces are very, very detailed, whereas the Sphinx seems to, have gone through the trials of nature. You can see the nose missing, and the face has a lot of scoring and scratching, things like that. So what's going on there? Well, obviously we're talking physical weathering here by a lot of wind and water. And a lot of people think, well, water in a desert. Well, yes, it does rain in a desert, not as often. But when it does rain, certainly water has a weathering effect as well. Okay? A lot of wind abrasion, right? A sandstorm picks up sand and sand blasts the surface. If you ever had wind pick up dirt and hit you in the face, you can easily feel how abrasive that is. Okay? So beautiful monuments, but someday they will be completely weathered away. All right? Going to put up some photos, describe one observation about each of the photos. We'll talk about them a little later on. But look closely at the photos here and write down just a little description on it or next to it of what you think's going on or what you're observing. All right, so hit pause and make a little note on each one what you think's going on there. Okay, and like I said, we'll go through that in just a minute. All right. So start out with your formal definition of weathering, right? Read that through, the breakdown of rock and other materials there, right? We call that weathering, and there are different types, of course. You could see everything being broken smaller. We're focused on physical weathering today. We'll talk about chemical weathering later on. All right. There's your formal definition. Make sure you get it in your notes. Okay, the breakdown of rocks on or at the surface into smaller fragments. We call those sediments. We're talking about physical or mechanical weathering. Those two are the same, folks. Okay? Most of this happens at the Earth's surface, right? We have the hydrosphere, the water layer, and the atmosphere, and you have all this interaction of energy at the Earth's surface, and rocks just can't hold up, right? They can't stand the test of time forever. Okay. How do we define physical weathering? Well, there it is. We're breaking down into smaller pieces, right? They're going to be different sizes. It's still the same substance. It's not a chemical change. You're just changing the size. As you make the pieces smaller, you increase the surface area, right? Makes them more prone to weathering even more. And of course, you can see beautiful pictures here. A lot of sandstone, a lot of sedimentary formation going on there. That's been sculpted out by wind and water over time. Okay? Frost wedging is a type of physical weathering, and you can see that water gets in the cracks, and when water freezes, we all know it expands. And it doesn't matter what the material is. Water is an amazing force. It'll crack part of your engine block in a car we talked about, right? If your antifreeze goes bad and you don't change that, it too will freeze and expand. And when that happens, you get what's called frost wedging, all right, or frost action. And the more often that you go above and below the freezing point, the greater the effects become. And that's why we get these big potholes in the spring. I'm sure you've seen, in the road, or you've heard your parents talk about them, or maybe you've hit them in the car while driving with the family. And that's because at night it would go below freezing in the early spring, and then in the daytime would go above, and then it would go below freezing, and you would get this expansion, contraction, the water would get deeper, freeze, and it just makes these monster holes. Even solid rock eventually succumbs to frost wedging if that temperature goes above and below freezing frequently. All right? The top of mountains, this happens a lot, right? During the day, it goes just above freezing, and then at night goes back down. That happens almost all year round. So you get a lot of this frost wedging at the top of mountains, especially in New York State. Okay? Here you have roots, tree roots, actually growing into a rock. And they will, patiently, they'll get moisture from the surroundings, they'll keep growing and spreading that rock. They call it root action or root wedging. It will absolutely split rock. If you have a tree that's too close to your house, it's sad to cut trees down sometimes when they're big, old, and pretty, but those roots will absolutely penetrate the foundation of your house and compromise its integrity. So when you're doing plantings, you want to make sure you know how big the tree is going to get, so you know how far away to put it. But if you move to a house where there are a lot of big trees close to the house, it's a consideration because the roots will crack into the foundation. Plus, if you get a big storm, older trees tend to come down eventually. Anyway, very rough force of nature there. You can see trees started out as just a little sapling probably and split that rock as it grew older and older. Okay. Abrasion, I'm sure you've all been running and taken a fall and you scrape your elbow or your knee. That's an abrasion. Well, Mother Nature also does abrasion, right, with wind. And it'll turn that jagged sample a bit more smooth and rounded. Also does it with water, right? Water will rub against things, abrade until it's smoother and rounder. So those two are similar. Water will make it the smoothest. Wind will still leave these little pitted marks, but both will absolutely smooth out the particles. All right, we call that abrasion. And you can see these examples on the bottom. Here's water abrasion, nice and polished. Whereas wind abrasion leaves it a little more pitted, but still rounds it out. Okay? And that's another form of physical weathering. So make sure you get that in your notes there. Okay? And another one here we call exfoliation. This one should make sense to you. During the day, the sun heats things up. When you heat things up, what do? They expand. Then it gets colder at night, so they contract. And then during the day, it expands and contracts. And what do you think is going to happen if you constantly expand and contract and expand and contract these solid materials? Right, it's not rubber, but even this will even happen to rubber, though. Eventually, what will happen? Well, hopefully you said break apart. Eventually, right, during the day, it gets hot. During the night, it gets cold, it contracts, and eventually it starts to break apart. Okay? So even without any water, it too will start to crack from this exfoliation, this constant fluctuation in temperature. That's why they put these joints in sidewalks. I'm sure you've seen that. Because during the summer and during the day, the sidewalk wants to expand, so it needs room to expand. And at night, it's going to contract. So if you don't have these joints, they call them expansion joints, then your sidewalk won't survive. And if you're going to redo a sidewalk, if you hire somebody to do a sidewalk, you got to make sure there's joints every couple of feet. Without that, you're just wasting your money. It'll be destroyed inside of a year or two. They also have these on bridges. If you ever go over a bridge and you're driving and you hear da-dum, 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 I know you know what I'm talking about. There's little expansion joints in the bridge. And same thing. If the bridge can't expand and contract, well, then it's going to crack and fall apart. So if it's built properly, you have to account for this expansion. In the weathering world, we call this exfoliation. Okay? So now, back to those pictures. You tell me what's what. The first one, clearly there's a tree going in there. Hopefully you called that a little root action. The second one, you saw this picture earlier up in the mountains. You get that constant changing temperature, but with moisture. So you're going to get frost wedging. All right, similar with C there, right? Frost wedging, frost action, same thing. Over here you have running water, so hopefully you put abrasion. Over here, it may be tough to tell from the picture, but it gets hot during the day, cold at night, that constant changing, expansion, contraction, right? That's your exfoliation. And over here you can see a crack with some water in there. So again, if it freezes, you'll get that frost action. Okay? All right, there's a couple summary questions that follow this. Work hard on those, and we'll go through them in the meet. See you there.